On your mark, get set, go.
Direct methods of measuring depreciation. Economic age-life method. The economic age-life method, straight-line depreciation method, or age-life method, is a mechanical method of handling depreciation borrowed from the accounting profession. This method allocates a uniform percentage of value loss each year over the economic life of the improvement. The accountant is interested primarily in book depreciation or in allocating a penalty against original cost over a number of time periods. The appraiser is concerned with the actual loss in value as of the date of the appraisal. The economic age-life method is the simplest to understand and use. It is based on the assumption that depreciation occurs at an even rate throughout the projected life of an improvement. In the economic age-life method, depreciation is estimated by comparing the effective age of the structure at the time of valuation with its total economic life. The measurement of depreciation by the economic age-life method is the ratio of an improvement's effective age to total economic life. The formula for depreciation then is effective age divided by the total economic life, which is multiplied by effective age plus remaining economic life. And that equals the depreciation. By using the formula for depreciation, what is the depreciation suffered by the following single-family residence and its corresponding improvement value if the cost new of the residence is $400,000? The total economic life of the residence is estimated to be 50 years, and the appraiser has determined that 5 years is the effective age for the residence. So the effective age divided by total economic life, which is 5 years. Okay, let me start that over. The effective age of 5 years is divided by the total economic life of 50 years, which equals the depreciation 10%. Your cost new is $400,000 less the depreciation of $40,000 equals an improvement value of $360,000. Cost new is the replacement, reproduction, original, or trended reproduction cost. The economic age-life method is the simplest method to employ, and it is the preferred method of most real estate appraisers. Nevertheless, it does have a few limitations, and for the reasons listed below, the appraiser must exercise discretion in its use. It is often assumed that every improvement depreciates on a straight-line basis over the span of its economic life. This assumption is generally not true. Depreciation varies with market conditions and the economic cycles of the improvement neighborhoods. All value loss is lumped into an overall estimate of depreciation. Effective age is subjective and dependent on the skill of the appraiser. Total economic life can be difficult to estimate because it is based on the future. It does not make any allowances for unusual functional or external obsolescence. Effective age may or may not be the same as actual or chronological age because maintenance, design, and location are factors that may increase or decrease the aging process. The remaining economic life of the improvement, in most cases, is something less than the remaining physical life. Within the same improvement use type, location is an important consideration in the determination of economic life. For many uses, economic life in a large, fast-growing, and relatively new city is much shorter than the economic life expectancy for the same property use in an older, smaller city. The economic age-life method is illustrated in Table 10.3. Table 10.3, Economic Age-Life Method. Comparable 1. Sale price, current, for A is $292,500, less the site or land value, which is well documented, which is B, is $75,000. So your improvement value of C is A minus B, which equals $217,500. Cost new of the improvement, which is D, is then equal to cost new of the improvement is $294,000, which is D. Depreciation amount, which is E, which is your D minus your C, is $76,500. The depreciation percentage, which is F, and it is your E amount divided by the D amount, is 26%. Your effective age is 10 years. Annual depreciation is H, which is your F amount divided by your G amount, which is 2.6% or 0.026. And your estimated total economic life is 1.0 divided by your H amount, which is 38.5 years. And cost new is equal to replacement, reproduction, original, or trended reproduction cost. Comparable number 2 of the economic age life method. Your sale price current is $319,500 less the site land value, which is well documented, of $75,000, gives an improvement value of $244,500. Cost new of improvement is $313,500. Depreciation amount is $69,000. Depreciation percentage is 22%. Effective age is 9 years. Annual depreciation percentage is 2.4% or 0.24. Estimated total economic life is 41.7 years. Cost new is the replacement, reproduction, original, or trended reproduction cost. Modified economic age life method. The modified economic age life method of measuring depreciation recognizes the effect of curable items of both physical deterioration and functional obsolescence. An estimate of the curable physical deterioration and the curable functional obsolescence must first be calculated and then deducted from the current cost new of the improvements. The effective age will likely become less after the curable items are fixed. To calculate incurable depreciation from the cost new of the improvements as of the effective date of appraisal, subtract the estimate of curable depreciation, which is the sum of curable physical deterioration and curable functional obsolescence. Multiply the result by the ratio of effective age to total economic life. Correcting the curable items may increase the remaining economic life and decrease the effective age of the improvements. This method of measuring depreciation does not differentiate between incurable, short-lived, and long-lived components of depreciation. The following equation is the modified economic age life formula, and Table 10.4 illustrates the calculation of depreciation by the modified economic age life method. Cost new less curable depreciation multiplied by effective age divided by total economic life equals incurable depreciation. Curable depreciation plus incurable depreciation equals total depreciation. Table 10.4, Modified Economic Age Life Method. Improvement, 50,000 square feet at $60 per square foot. That's $3 million. Other improvements, so you'll add $50,000. Cost new then is $3,050,000 less physical curable and functional curable repairs, less $25,000. Subtotal cost new less curable depreciation repairs is $3,025,000. Effective age after repairs is 10 years. Total economic life, 50 years. Physical incurable deterioration is 10 divided by 50 multiplied by $3,025,000, which is, I'm going to assume either the 0.20, but I don't think that's right. Well, I'm at the 605,000. The physical incurable deterioration, I guess it's figured the 10 divided by 50 times the 3,025,000, which would equal the 605,000 that you're going to subtract from the 3,025,000 above to give depreciated cost of improvements $2,420,000.
Well, no, 10 divided by 50 is 20.
The 0.20?
Yeah.
Okay, so then you're taking the 0.20 and multiplying it by the 3,025,000 to give you the 605,000 that you're subtracting back from the $3,025,000. So that means depreciated cost of improvements is $2,420,000. What are you smiling at over there? Your site value then becomes the $750,000. And indicated value by cost approach is $3,170,000. And cost new is the value by cost approach. No, the cost new is the replacement, reproduction, original, or trended reproduction cost. Be sure and go over that chart to understand what they're doing there, because it didn't read very well.
It didn't.
It was ugly. Breakdown, observed condition method. The breakdown method requires a separation of elements of depreciation into various categories. During the physical inspection of the neighborhood and subject property, the causes of depreciation are divided into classes and types. This method can be the most complete and accurate way of handling the problem of depreciation, and a thorough understanding of this method is an excellent way of acquiring an understanding of the problems posed by the calculation of depreciation and its relationship to market value. Although the method is not particularly adaptable to mass appraisal, its value to the appraiser and its deep penetration into the specific causes and individual measurements of depreciation. A working knowledge of the breakdown method provides the appraiser with a better understanding of both the cause of depreciation and the methods of measuring depreciation. The principal techniques that may be used to measure physical deterioration, functional obsolescence, and external obsolescence are described in Table 10.5 and shown graphically in Figure 10.3. The following is a detailed explanation of how various components of depreciation can be measured by the breakdown method. Do you want me to read this? Oh, it'll read probably all right.
Yeah.
Table 10.5, breakdown method of estimating depreciation. The item of physical deterioration, curable and incurable.
Now read across by the line. Curable, cost to cure, replacement cost is the same. Incurable, age-life ratio. I think that's how it reads.
Okay, so your item of physical deterioration of curable has a reproduction cost, which is cost to cure, and the replacement cost is the same. The incurable item.
Incurable physical deterioration, I mean.
Okay, so incurable physical deterioration item has an age-to-life ratio reproduction cost, and it has the same replacement cost. So deficiency requiring an addition is a functional obsolescence, and it's curable.
Now read physical obsolescence, curable, then deficiency, then cost. Yeah, read that.
But that's not how we did it in the line above.
Well, just do it that way. Bold first.
Okay, so functional obsolescence, curable. The deficiency requiring an addition. Cost to add, less cost if included in improvement today, has the same replacement cost. Deficiency requiring substitution or modernization. Cost of existing item less physical deterioration of existing fixtures and salvage value plus cost to remove and install new fixtures has a replacement cost of the same. Super adequacy, and then current cost new less physical deterioration charged plus cost to remove less salvage value has a replacement cost to remove less salvage value.
What? Repeat that. Read that again.
It says the replacement cost is to remove less salvage value.
No. Read it all the way through. Replacement cost is cost to remove less salvage value.
Exactly what you said.
Are you getting tired?
What did I do?
No, you're going fast and skipping words.
I'm not skipping. I'm not going fast either. So, functional obsolescence of incurable is deficiency caused by item not included in cost new but should have been. Capitalized income lost by improvement capitalization rate less cost if included in cost new, or income loss times gross income multiplier has the same replacement cost. Deficiency caused by an item included in cost new but should not have been. Current cost new less physical deterioration already charged less value added has a replacement cost of the same. And super adequacy, current cost of super adequacy less any physical deterioration already charged present value of added cost of owning less value added. And the replacement cost is present value of added cost of owning less value added. External obsolescence. Capitalize the income loss due to external obsolescence with allocation to improvements in sales comparison. Replacement cost is the same.
You don't have to read that last one.
You don't need to know that cost new is the replacement reproduction original or intrinsic reproduction cost. You're welcome. Figure 10.3, breakdown method organization chart. So breakdown method of measuring depreciation, observed condition. You have three conditions: physical deterioration, functional obsolescence, and external obsolescence.
No, those are three breakdown of measuring depreciation. Physical deterioration, functional obsolescence, and external obsolescence. Those are not conditions really, those are depreciation.
Well, I was just saying, this chart is saying that the observed condition of the depreciation is the physical deterioration, functional obsolescence, and external obsolescence.
Okay.
So under physical deterioration, you have curable, deferred maintenance, and incurable, which the incurable leads to short-lived items and long-lived items. That's really small print.
Yeah.
So the functional obsolescence leads to, it has curable and incurable. Curable leads to deficiency normal, deficiency modernization, substitution, and super adequacy. Incurable leads to deficiency normal and super adequacy.
Actually, those are, like on the incurable, the short-lived and long-lived, those are different types of incurable.
Oh, underneath the physical deterioration?
Yeah, those boxes are, the dark gray boxes are the types of curable of the box that they're attached to. So that curable, you have deficiency normal, deficiency modernization, and substitution, and super adequacy. Those are all functional obsolescence curable types. And then you have functional obsolescence incurable types, deficiency normal, and super adequacy. And then you have external obsolescence.
Yep.
So now they're going to talk about those physical deterioration.
So are you going to pause or are we going to keep going?
Now keep going. We read the chart.
Okay, just making sure because I had me a little yellow line.
Past. Go past it.
Physical deterioration. Curable physical deterioration Get out from underneath the bed. The table.
Which is the first box in the chart.
Which is the first box in the chart. Curable physical deterioration is sometimes referred to as deferred maintenance and typically applies to relatively minor items that are in need of immediate repair or replacement on the effective date of appraisal. These items are considered to be 100% depreciated, thus making no value contribution to the improvement. Because these repairs must be performed for the building to continue to function, they are considered curable. There are several major tests that can be applied to items of physical deterioration to determine whether they should be categorized as curable or incurable. If spending the money to cure the item results in a value increment equal to or greater than the expenditure, the item is typically considered curable. If spending money to cure the item does not result in a value increment equal to or greater than the expenditure, but generally allows other existing items to maintain their value, then the item is typically considered incurable. This type of depreciation is measured by the cost to cure the defect. Defect, it's the same word. Tomato, tomato. You're from Oklahoma and you say sir.
Defect is something wrong with something. To defect is to leave a country. The country of deterioration.
You need to go back to Oklahoma. You're just a windstorm away from California. This type of depreciation is measured by the cost to cure the defect, restoring the items to new or relatively new condition. The amount to deduct from cost new is the cost to correct or repair the defect. If, for instance, the curable physical deterioration is due to a broken window, the cost of replacing or repairing the window is $250. Then $250 is the amount of curable physical deterioration, even though the current cost new of the window as part of the original construction was only $200. If the window had been installed during the original construction, the contractor's price would have been less because of purchasing all windows for the improvement and installing all of the improvements windows as part of the total construction. Currently, the repair of only one window costs more than the original purchase and installation. In order to fall into this classification, the defect must be in such condition that it should be cured as of the date of appraisal. A roof that is 50% deteriorated would not be cured as of the date of appraisal, nor would an exterior paint job that will last for 2 more years because they are incurable items. The steps the appraiser must take in estimating curable physical deterioration are as follows. Number 1, identify each item deferred maintenance during the on-site property inspection. Identify the cost new of each item of deferred maintenance that is part of the total cost of the improvement. Number 2, estimate the cost of curing or correcting each item of deferred maintenance. Number 3, add each estimate of cost to curable physical deterioration from step 2 to determine the total curable physical deterioration from the property. Table 10.6 provides an example of calculating this form of deterioration. The physical inspection of the subject improvement finds that the 8-year-old single-family residence needs immediate repair of a broken screen door, replacement of several roof gutters, and replacement of deteriorated wood on several areas of the roof eaves. On the basis of cost new estimates, $200 for the screen door, $400 for the roof gutters, $1,000 for the eave wood, and discussions with several contractors, the cost to cure, which is the measurement of curable physical deterioration, the 3 items is estimated at $250 for the screen door, $450 for the roof gutters, and $1,250 for the deteriorated wood on the roof eaves. The total curable physical deterioration is $1,950. In the example in Table 10.6, the total physical deterioration curable items components are estimated to be $1,950, which is measured by the cost to cure. The cost of new of the short-lived items components is estimated to be $1,600. Table 10.6. Curable physical deterioration. Item, repair of screen door. Cost new, $200. Cost to cure, $250. Repair of roof gutters. Cost new, $400. Cost to cure, $450. Repair of roof eaves, $1,000. Cost to cure, $1,250. Total, $1,600 for cost new for all the items. The cost to cure for all the items total is $1,950. Incurable physical deterioration. Incurable physical deterioration is further broken down into short-lived and long-lived improvement components. Items of deterioration classified into one of these two categories are not economically feasible to cure as of the effective date of appraisal, but probably will have to be replaced in the foreseeable future. This usually includes all basic structural or long-lived items, as well as short-lived items that are still serviceable. Long-lived items are assumed to have the same age life expectancy and, by default, are treated together. Examples of long-lived items include exterior walls, structural framing, the roof structure, foundation walls, and underground piping. A short-lived item is an improvement component expected to have a physical life shorter than the physical life of the structure as a whole. Examples of short-lived items are roof cover, floor covering, appliances, water heater, and the like. Cannot believe you. Both incurable physical deterioration, short-lived and long-lived, are measured by the age-life ratio, which is the ratio of actual age, physical age, of the improvements to the estimated total useful life of the improvement. Regardless of how long physical components may last, an economic factor must be considered, and this is why the term useful life is used rather than physical life. The resulting ratio is applied to the remaining cost new of the incurable physical short and long-lived improvement components. This method is used to estimate physical deterioration only. The age of short-lived items may be the actual age of their effective age. Actual age is used more often than effective age in measuring incurable short-lived deterioration, because effective age is subjective, relying on the appraiser's judgment. Total useful life usually is developed from many sources, such as historical information, cost estimation surveys, manufacturer's warranties, appraiser observation, and discussion with property managers, contractors, and others. One drawback to this method is the difficulty of determining the useful life from the market. Typically, useful life is longer than economic life. The steps required to develop incurable physical deterioration short-lived are as follows. Number 1. Estimate the actual age, effective age of the short-lived components. In most circumstances, the effective age of a short-lived item component is the same as or very similar to its actual age. Number 2. Estimate the total physical life of the short-lived item or component. Number 3. Using the depreciation formula, divide the item component's respective actual effective age in step 1 by its estimated physical life in step 2 to estimate the incurable physical deterioration short-lived. Number 4. Estimate the cost new of the short-lived item component as of the date of appraisal. Number 5. Estimate the cost new, step 4, by the item component depreciation ratio. Excuse me. Sorry, I'll start that over. Number 5. Multiply the cost new step 4 by the item component's depreciation ratio developed in step 3 to develop the indicated amount of physical deterioration attributable to the respective item component. Number 6. Repeat steps 1 through 5 for each item component of incurable physical deterioration short-lived. In the inspection of a single family property, it is noted that the exterior painting cost $8,000 and expected to last for 10 years, and that the current painting has an actual age of 4 years. The 2-year-old hot water heater costs an estimated $1,000 as part of cost new and lasts for 10 years. The 6-year-old carpeting will last for 15 years, and its current reproduction cost is $12,500. The mathematical calculation of incurable physical deterioration follows in Table 10.7. The total physical deterioration of the incurable short-lived components is estimated to be $8,400. The cost new of the short-lived items components is estimated at $21,500. Table 10.7. Incurable physical deterioration short-lived. Item: exterior painting. Cost new, $8,000. Actual age is 4. Total useful life is 10. The ratio is 4 divided by 10, so the depreciation is 40%. So the incurable physical deterioration short-lived is $3,200.
Depreciation. Okay, so then that ratio of 4 divided by 10, it's actual age divided by the total useful. Well, they say useful life here, but I think it's some other kind of age, effective age or something like that. But go ahead.
Does it say up top?
It doesn't call it that, effective age.
Oh, okay.
This is a different term they're using in this book, but I think
Okay.
that's what it is.
Okay.
But just, it's age, actual age divided by useful life age.
So your item, hot water heater, cost new $1,000. Actual age $2 years $2. 2. Total useful life is 10. So the ratio is 2 divided by 10. Depreciation is 20%. So your incurable physical deterioration short-lived is $200 for the hot water heater. For the carpeting, the cost new is $12,500. The actual age is 6. Total useful life is 15. The ratio is 6 divided by 15, making the depreciation 40%. The incurable physical deterioration short-lived is $5,000 for the carpeting. So the total cost new of all 3 items is $21,500. So you add the incurable physical deterioration short-lived for all 3 items and get a total of $8,400 for that. It's depreciation, right? That $8,400? Okay. Incurable deterioration long-lived item components include all item components not treated as items of deferred maintenance or as short-lived items. They are assumed to have the same age and life expectancy and, as a result, are all treated equally. Some examples of long-lived item components are the improvements, foundation, exterior walls, structural framing, and roof support system. Before the incurable deterioration long-lived can be calculated, the cost new incurable physical deterioration and incurable physical deterioration short-lived must be removed from the total estimated cost of the new Before the incurable deterioration long-lived can be calculated, the cost new incurable physical deterioration and incurable physical deterioration short-lived must be removed from the total estimated cost new of the improvement to avoid double counting. The deterioration of curable physical deterioration long-lived item components is measured by estimating an age-life ratio and applying it to all components of cost that have not already been treated for physical deterioration. The steps to calculate incurable physical deterioration long-lived are as follows. Number 1, estimate the total cost new of the improvement. Number 2, sum the cost new of the curable physical deterioration item components and the cost new of the incurable physical deterioration short-lived item components.
Oh, okay.
Number 3, subtract the result in step 2 from the total cost new in step 1 to derive the cost new of the incurable long-lived item components. This step must not be avoided because double depreciation of certain item components results in providing the appraiser with an inaccurate estimation of depreciation. Number 4, compute the age-life ratio of measuring depreciation. Number 5, multiply the result in step 4 by the remaining cost new in step 3 to derive the depreciation due to incurable physical deterioration long-lived. As an example of cost new of a single-family residence is $185,000. The total cost new of curable physical deterioration and incurable physical deterioration short-lived items included in this amount is $13,500. The actual age of the structure is 15 years, and its total useful economic life is 60 years. No other forms of depreciation are evident. The example in Table 10.8 utilizes the steps needed to calculate incurable physical deterioration long-lived. Table 10.8, incurable physical deterioration long-lived. Cost new is $185,000. Less total cost new of curable physical and incurable physical short-lived items is $13,500. Subtract the $13,500 from the $185,000 and you get cost new of long-lived items $171,500. The actual age is 15 years. Total useful life is 60 years. So ratio applied to cost is the 15 divided by 60. So you're going to multiply the 0.25 or 25% by the $171,500 to get a total incurable physical deterioration of long-lived items to equal $42,875.
So you subtract, you get your cost new, then you subtract your curable physical and incurable physical, the short-lived items, from the cost new, and that gives you the cost new of long-lived items. Okay. Then you apply the age-life ratio and multiply that by the cost new of long-lived items. Okay. Is that the end of it?
Mm-hmm.
Oh, that was the end?
Yeah.
Okay. Next time, we will have functional obsolescence.